All right, everybody, welcome to Math with Grace. Today we're going to be working through Math 7, Book 704, Lessons 11 through 15. Lesson 11 begins on page 42, and it's titled Simplifying and Solving Expressions in Equations. It says sometimes we must first simplify the expressions on both sides of an equation before we can solve the equation. Now, up until this point, we've been doing simply one side at a time, but if we think about it, what we're doing, we can just do all over the place, okay? So the expression here is n minus the quantity 6 plus 3 equals 3 times 2. We're just going to simplify both sides of the equal sign until they're as simple as they can get, and then continue to solve for our variable. So in this case, 6 plus 3 is 9, so we end up with n minus 9. Here, 3 times 2 is 6, so now we have n minus 9 equals 6. Now that everything is simplified, we can continue to solve for our missing variable. And 9 is being subtracted from n, so we're going to do the opposite and add 9 to both sides and solve n equals 15. When we were adding here, since we weren't crossing the equal sign, we didn't have to add both sides. When we multiplied here, we didn't have to multiply both sides because we weren't crossing the equal sign. In this stage, we want to get rid of this n. We want it to cross to the other side. And that's why we add the opposite to both sides, okay? So we're going to dive right in here to look at 1a. For 1a, we have n minus the quantity 5 plus 1 equals 5 times 2. We're going to simplify both sides of the equal sign and then solve for our variable. So n minus doesn't change. 5 plus 1 is 6. And that's going to be equal to 5 times 2, which is 10. Okay? Now we need to actually move things, right? N wants to be by itself, so we need to get rid of everything on that side of the equal sign. To do that, 6 is being subtracted. We're going to do the opposite and add to both sides. This, we weren't moving. We were just simplifying it, so we didn't have to do something to both sides at the same time. This we are moving. The n wants to be by itself. We need to move it, this negative 6 out of the way. And we do that by adding 6 to both sides. So we have n. Negative 6 plus 6 is 0 equals 10 plus 6 or 16. Now they want us to check our work. So when we have an n, we're going to write a 16 instead. So I have 16 minus 5 plus 1. Is equal to, I'm just going to write a 10 because that's what 5 times 2 is, okay? So 16 minus 6 equals 10. Is that a true statement? Yes, it is. Let's move to the top here of page 43. For here, we have 8 times n, or 8n, plus 2 plus 4 equals 32 minus 2. We need to combine our like terms, and that is these two constants and these two constants, but we're not going to cross the equal sign just yet. We're going to stay on our lane. So we have 8n. 2 plus 4 is a 6. 32 minus 2 is 30. Now everything is combined on their separate side of the equal sign, simplified to their simplest form. Now we can solve. We need to get the term 8n by itself. 6 is being added to that. We're going to do the opposite and subtract 6 from both sides. So I have 8n, 6 minus 6 is 0, is equal to 30 minus 6, which is 24. 8 is being multiplied by n. N wants to be by itself. So we are going to do the opposite and divide both sides by 8. 8 over 8 is 1. N is equal to 24 divided by 8. How many 8s are in 24? There are 3. Now we need to check our work. Is n actually equal to 3? So let's substitute it in here. I have 8 times n, or 8 times 3, plus 6. I'm kind of starting at this spot here, equals 30. Okay? 8 times 3 is 24. So is 24 plus 6 equal to 30? Now, I could have made an error and starting at this part wouldn't have worked, but I still would have been able to check and find that error at this point, right? Because 24 plus 6 is 30, 30 plus 30, or sorry, 30 equals 30. Okay, last one. 3, we have 2 times 5 equals n plus 9. 2 times 5 is a problem that we can multiply. 2 times 5 is 10. We cannot add n plus 9. They are not like numbers, so they stay separated. But now we can solve for n. Now that this side is simplified, we can solve for n. 9 is being added to n, so we're going to do the opposite and subtract 9 so we can get n by itself. 9 minus 9 is 0, so I have it n is equal to 10 minus 9. 10 minus 9 is 1. So n is equal to 1. Let's check our work. 2 times 5 is equal to 1 plus 9. 2 times 5 is 10. 1 plus 9 is 10. 10 is equal to 10. Our answer is correct. Okay, so not really anything different going on here in lesson 11. It's just that now there's just more, all right? And I've talked about that before, how we're going to keep learning a new topic, and then it's going to be added to the topics we've already learned, right? The concepts that we've already learned. We've already learned how to simplify one side of the equal sign. Well, now we're just simplifying things on both sides of the equal sign. If you can simplify on one side, you can simplify on the other. And that's it. Math just is going to grow, and topics are just going to be added and compounded together, okay? But nothing you guys can't handle. You're doing a great job. All right, that's it for lesson 11. Go ahead and finish the We Remember and meet me back here when you're ready for lesson 12. Lesson 12 begins on page 47, and it's titled Simplifying Complex Fractions. It says a complex fraction has a fraction within a fraction. The fraction part may be in the numerator or the denominator or both. Since a fraction bar indicates division, complex fractions can be simplified by dividing the numerator by the denominator. And then it says solve as usual. So we have 2/3 divided by 3. Now we can't divide a fraction by a fraction, right? Because technically, right, this is the same as 3 over 1. So we multiply by the reciprocal. We flip, flop, multiply. We flip it over, so our 3 over 1 becomes a 1 over 3, and we multiply. For this problem, we have 5/6 divided by 7/12. Again, we can't divide a fraction by a fraction, so our numerator stays the same. And then we multiply by the reciprocal of the denominator. So the 1 in the bottom gets flip-flopped, and then we multiply. So 7/12 becomes 12/7. And then we multiply, reducing if we can, changing it over to a improper fraction. Okay? Not improper fraction, a mixed number. From an improper fraction to a mixed number. So here we have 2 5/6 divided by 1 1/2. Again, we cannot divide a fraction by a fraction, so we have to flip-flop multiply. But before we can do that, we have to change both of our numbers to improper fractions. Then we can find the reciprocal and complete our problem. Okay? So, I know that seems like a lot. There's plenty of practice problems for us to do here. But first thing they want us to do in this first section is to write these as complex fractions. So here is what they've given us. They want us to write it as a complex fraction. So 5 divided by 2/3, 5 is my numerator, and 2/3 is my denominator. So it's just 5 divided by 2/3. Remember, the division bar represents division. The fraction bar represents division. So for this one, 4 and 1/8 divided by 6 and 1/2. We have 4 and 1/8 divided by 6 and 1/2. For 2, we have 5/6 divided by 2/3. So 5/6 divided by 2/3. Now when I'm writing a fraction over a fraction, I like to have my fraction bar pretty big, just to make sure it's easy to see the fractions from each other. Part B is 1 3/4 divided by 3/4. So 1 3/4 divided by 3/4. And then we have 1 2/5 divided by 2. So 1 2/5 divided by 2. And you could write 2 over 1 if you wanted, but 2 is fine as well. So now we are going to be simplifying and solving these problems here for problem number 3. So looking at 3, we have 1/2 divided by 2 3/4. So if we were writing it from here back to this part, right, we would have 1/2 divided by 2 3/4. Now, our 2 3/4 needs to be changed to an improper fraction. And remember, to do that, we take the denominator times the whole number, and then we add the numerator. So this is 1/2 divided by 4 times 2, which is 8. 8 plus 3 is 11, so 11/4. The denominator stays the same. Now, we cannot divide a fraction by a fraction, so the first part stays the same, and then we flip-flop multiply. So this one we're taking the reciprocal of. We're flip-flopping it over. So it's going to become 4/11, and we're going to multiply. Okay, flip-flop multiply. Now, before we multiply, let's go ahead and reduce where we can. Our 1 and 11 are both prime numbers, so they're not going to, well, 1's technically not a prime number, but they're both as small as they're going to get, right? But 2 and 4 have a factor in common, and that's a factor of 2. There is 1 2 in 2, and there are 2 2's in 4. So now we're going to multiply across the numerators and multiply across the denominator. So 1 times 2 is 2. 1 times 11 is 11. So we have the answer being 2/11. Taking a look at part B, we have 1 3/4 divided by 2. We need to change both of these to improper fractions. So we're going to multiply the denominator times the whole number and add the numerator. 4 times 1 is 4, plus 3 is 7/4. Divided by 2, to make that an improper fraction, we're going to put it over a 1. Now we cannot divide a fraction by a fraction, so our first number stays the same, and then our second number is going to be flip-flop multiplied. We're going to take the reciprocal. We're switching it around. So it's going to become 1/2, and we multiply instead. Now, remember, we can only reduce a numerator with a denominator. So even though 2 and 4 have a factor of 2 in common, we can't reduce because they're both in the denominator. All right? So we multiply across the numerators, we multiply across the denominators. 7 times 1 is 7. 4 times 2 is 8. So the answer is 7/8. Okay, last one. We have 2 1/2 divided by 2 3/4. Both of these need to be switched over to improper fractions. Okay. 2 times 2 is 4, plus 1 is 5. So the first one becomes 5/2, divided by 4 times 2 is 8, plus 3 is 11/4. Remember, whatever's our denominator here becomes our denominator here. Now again, we cannot divide a fraction by a fraction. So our first fraction stays, and then we flip-flop multiply. We take the reciprocal of this, so it becomes 4/11, and we multiply. Let's reduce if we can. 2 and 4 have a factor of 2 in common. There is 1, 2, and 2, and 2 2s and 4. 5 and 11 do not have a factor in common, so this is reduced as much as we can. Multiplying across the numerator, 5 times 2 is 10. 1 times 11 is 11. So we have 10 elevenths. Okay, the trickiest part of this is switching over from a mixed number to an improper fraction, right? You've got to do that carefully, because if you mess that up, then the rest of the problem's messed up anyway. We can't divide a fraction by a fraction, so we have to take the reciprocal of the second one. The first one stays the same. We flip the second one over and we multiply. I call it flip-flop multiply. The flip-flopping in math terms is called taking the reciprocal. It's where you switch the numerators and the denominators, flipping it over, right? That's why I call it the flip-flop multiply, because we went from dividing, we flip-flopped, and now we're going to multiply. All right? Okay. Work through these problems carefully. That's lesson 12. Go ahead and finish the We Remember, and meet me back here when you're ready for lesson 13. Lesson 13 begins on page 52, and it's titled Using Fractional Equivalents of Percents in Story Problems. It's kind of a big title. Don't let it freak you out. It's not that big a deal. It says here, when a story problem asks you to find a percent of a number, you usually multiply by the percent's decimal equivalent. Example being, on a quiz of 20 problems, Roland made a score of 65%. How many problems did he have correct? Well, 65% of 20 problems is our answer, right? So 0.65, we change our decimal into a fraction, we multiply, and we see that he got 13 problems correct. Okay. Sometimes, however, it's easier to multiply by the percent's fractional equivalent. So here's this example. 50% of the 28 students had completed their math lesson before lunch. How many students was this? How many students is 50% of 28? Well, in this case, instead of multiplying 28 by 0.5, they've changed it over to a fraction, 1/2. 0.5 and 1/2 are the exact same thing. Okay, so if you're using a calculator, deciding to multiply by 1/2 makes no difference. Okay, but if you are doing this by hand, which is fine, if that's how you're choosing to do it, then the 1/2 might be an easier way, because half of 28 is the same as dividing by 2, right? 30 people were expected at the meeting, but only 40% showed up. How many people attended the meeting? 40% of 30 is how much? Well, in this case, rather than multiplying 30 by 0.4, they've decided to change that 40% to 2/5. Some of that stuff we learned earlier in the year so far, right? And then they multiplied. If you're good at multiplying this, right, you would take 2 times 30 divided by 5, and you would get 12, right? If you're using your calculator, taking the 0.4 would probably be the easiest way. So it says, when a story problem asks you to find a percent of a number, decide whether it's easier or more accurate to solve using a percent or its fractional equivalent. Sometimes the fractional equivalents will give you an exact number where the decimal percentage may not. Okay? That being said, it is very much just a preference. A lot of times it'll just tell you what to do in the instructions. Okay? So let's take a look at problem number 1. At an auction sale, Dale bought a pressure canner for his wife for 20% of what a new one costs. If a new pressure canner costs $55, what did Dale pay for the used one? It says use the fractional equivalent of 20% to solve the problem. So even though they're saying, you know, you can decide, they're just telling you what to do. Okay? So remember, 20% of 100, because that's what a percentage represents, right, is the same as 20 over 100. We can get rid of those zeros and reduce. There's 1, 2, and 2, and there are 5 2s and 10. So the fractional equivalent of 20%, if you didn't remember from work previous to this, is 1/5. So it says, again, that Dale bought a pressure canner for his wife at 20% of what a new one costs. The new one costs $55. So 20% of $55 is what he paid. All right. So now, instead of 20%, they want us to use the fractional equivalent, which is 1/5 of $55 equals what? What did Dale pay for his pressure canner? Well, 55, this is basically being divided by 5, right? They have a 5 in common. So Dale paid $11. Remember, we're talking about money, and therefore we need to represent that properly, right? Dale paid $11 for his pressure canner. Okay, number 2. 48 students are enrolled in the church school which Ernest and Dale's children attend. 16 2/3% of them are in Alex's grade. How many students are in Alex's grade? So they're saying 16 2/3% of 48 students is how many? How many of them are in Alex's grade? It says use the fractional equivalent for 16 2/3 to solve this problem. Okay, 16 2/3%. What would be the fractional equivalent? It already has a fraction, right? So we need to change it into basically it's already in a fractional percentage. We need to change it to a fraction. Now, if you think back to, I believe it's book 2, lesson 15, we would know that 2/3 is the same as a 0.6. So 16.6% of 48 is how much? Well, we're going to move our decimal 2 spots, right? 0.166 repeating times 48 is where we're at. So if we take 0.166 times 48, we get 7.968. Now, obviously, you cannot have 7.968 of a person's, right? We're talking about students enrolled in a church school, right? We can't have 0.968 of a person. So the answer is taking this 7, rounding it based on a 9, and we would have 8 students, right? Because we can't have part of a person, right? It's just not possible. You got the whole person or none at all. So 8 students are in Alex's grade. Okay. So again, we are using our fractional equivalents of percentages and percents from fractions to solve a story problem, right? We're setting up our equation based on the question that they're asking, and then we're solving. Okay. Again, like I said, these problems just build and build, right? But nothing we can't handle because we are doing it one piece at a time. Great job. Go ahead and finish the We Remember here and meet me back when you are ready for lesson 14. Lesson 14 begins on page 57, and it's titled Converting Between Liters and Gallons. It says here it's useful to know how to convert between liters and gallons. We use gallons in this country, Canada and other neighboring countries. I guess there's only one other neighbor, but they use liters. Most countries do. We use gallons, but it's good to know how to switch back and forth. It says memorize, you know how I feel about that, but 1 gallon is approximately 3.8 liters. And honestly, if you are just trying to do a quick conversion in your head and precision isn't necessary, 1 gallon is about 4 liters. Okay, just to do a quick, if you're just trying to calculate, oh, well, I need 2 gallons of gas, but I'm paying liters because I'm somewhere that doesn't do. How many liters am I getting? If I have to pay by the liter, how many liters do I need? Well, for 2 gallons of gas, you need about 8 liters, and you can do your, your math just to figure it out. But if we want a more precise answer, even though it's still not completely precise because we still rounded, right? 1 gallon is 3.8 liters. That's the conversion that we're going to do. So I'm going to set these up the way we are learning to do these conversions. Again, we're doing them this way instead of the way the book shows because as we move forward, we are going to be converting more than one thing at a time. When you take science classes in high school, you're going to be converting more than one thing at a time, and it's just easier to set them up this way. So for our 50 liters, okay, to convert it over to gallons, we're setting it up being multiplied by a fraction where my liters go in the bottom, which is 3.8. And the thing that I want, which is gallons, is going to go in the top. Okay? That allows me to cancel my liters. And then I multiply across and I get 50 gallons divided by 3.8. And when I do that math, it is rounded, of course, but they've got it to be approximately 13 gallons. To go the opposite way, I'm starting with my 12 gallons, and I'm going to be multiplying it by a fraction with gallons in the bottom. Okay, remember the thing that I want to solve for, which in this case is liters, is always going to be in the numerator of my fraction. The thing that we have is always going to be in the denominator. I was given gallons, so gallons needs to be down here. That way I can cancel them. And then I multiply across. And so it's just 12 times 3.8 liters gives us our answer. They've rounded to approximately 46 liters. Okay? Now, down here in this little box, remember how I said it's almost 4? That's the number that they use. But when we're doing these problems in the book, this is the conversion that you want. 1 gallon is approximately 3.8 liters. Let's turn the page and do some of these together. All right, for problem number 1, we have 16 gallons is approximately how many liters? Rounding to the nearest whole gallon or whole liter. So we were given gallons. So in our fractional conversion, gallons are going to be in the denominator, and that's 1 gallon to 3.8 liters. A gallon over a gallon is 1, so they cancel, and we end up with 16 times 3.8 liters. It just turned off as I grabbed it. 16 times 3.8 is equal to 60.8. Since our instructions are telling us to round to the nearest whole gallon, I'm rounding a 0 based on an 8. So because that 8 is greater than 5, it's going to bump us up to 61 liters. For the next problem, number 2, we have 15 gallons is approximately how many liters? Since we were given gallons, our gallons are going to go in the denominator. And then my 3.8 liters is going in the numerator. That allows me to cancel a gallon for a gallon. And I end up with 15 times 3.8 liters. 15 times 3.8 is equal to 57. And that 57 has no decimal, so it is 57 liters. Works out perfectly. For problem 3, I have 64 liters is what I was given. So my liters are going to go in the denominator and my gallon in the numerator. This allows me to cancel out my liters, and I end up with multiplying across 64 gallons over 3.8. So on our calculator, we take 64 divided by 3.8, which gives me 16.842, and it goes on, but that will be enough. So 16.842 is more than we need, right? Because we're rounding this 6 based on an 8. The 8 is greater than 5, so it's going to bump that 6 up to 17 gallons. For our last problem, number 4, we're given 100 liters. Because we're given liters, our liters are going to go into the denominator, and that leaves our gallons to go in the top. 1 gallon is 3.8 approximately liters. Having a liter in the denominator allows us to cancel liters, and then multiplying across, we get 100 gallons divided by 3.8. 100 divided by 3.8 gives us 26.315. 26.315. We're rounding a 6 based on a 3. The 3 is not powerful enough to bounce the 6 up, so we round down to 26 gallons. So remember, when we're setting these up, what we were given goes in the denominator, and what we're looking for goes in the numerator, right? So if we were given 64 liters, our number for our liters goes in the denominator, and our number for our gallons goes in the numerator. And then we cancel out our measurement that we don't need anymore, and we multiply across, and sometimes we have to divide. All right, great job. Go ahead and finish the We Remember for this lesson, and meet me back here when you're ready for lesson 15. Lesson 15 begins on page 62, and it's titled Decimal and Percent Equivalents for Eighths. I believe book 2 we did thirds or something. I don't know. It says in this lesson we're going to concentrate on equivalents for 1/8, 3/8, 5/8, and 7/8. So taking a look at these, remember, to find these decimal equivalents, we would divide 1 divided by 8, okay? And we get 1 divided by 8 is 0.125. As a percentage, that is 12.5%. As a fraction, again, we can change the 0.5 to a 1/2, so 12.5%. And I don't expect anybody, I know the memorized squares here, I don't expect you to memorize these, okay? But as long as you can figure it out by taking the numerator divided by the denominator, you're good to go. So 3 divided by 8 is 0.375, or 37.5%, or 37.5. 5/8, or 5 divided by 8, is 0.625, or 62.5%, or 62.5%. And 7/8 is 0.75, or 87.5%, or 87.5%. All right? Okay. Working through these, as long as you know how to figure them out, memorizing is not necessarily the answer. I grabbed book 2 real quick. So here, remember book 2. So on page 63 is that other chunk of memorizing, right? Where 1/6 was 16 2/3, and 1/3 was 33 1/3, and so on, 66, okay? So to go back and review these, that's book 2, lesson 15. Now we're in book 4, lesson 15. And let's go ahead together and fill out this chart. So for 1/8, remember the decimal equivalent is 0.125, which gives me 12.5%, or 12.5%. 3/8 is 0.375, which is 0.5%, or 37.5%. 5/8 is 0.625, which is 62.5%, or 62.5%. And finally, 7/8 is 0.875, or 87.5%, or 87.5%. Now, as you can see, all of these eighths end in a 0.5 or a 1/2. That's just the pattern that they unfold there, and that's kind of the things that they want you to recognize. But that's it for lesson 15. Now, that's it for this book, right? When you finish lesson 15, you will go ahead and take your test. If you have any questions, as always, do not hesitate to contact me. Otherwise, until next time.